One type of abstract data type is a structure. A structure is a C++ construct that allows multiple variables to be grouped together. A structure is a way to implement an abstract data type. So first I want to give you an idea of when it would be cool to use a structure. Let's say that we keep student data in a program. So I'm going to draw a student. Okay, here's our student. And the kind of data we might need for this student, we might want the student's ID. We might also keep the student's name. We might also want to know what their GPA is, what their major is, maybe their age, and so forth. Well, if we have multiple students in our program, we could create multiple parallel arrays, which we covered in the last chapter, or actually it was chapter before last. So we could have a whole huge array of IDs, a whole huge array of names, GPAs, majors, age, and then keep up with which one belongs to what student by using the index values. So everything index 0 in all these arrays is talking about a student named Jill, let's say. However, there's a better way to organize that, and it's with a structure. So let's look at the syntax of creating a structure in your program. You would write the word struct, short for structure, and then we're going to have a tag or your structure name. So since I want to create information about a student, I'm going to name it student. Fantastic. Now we have the body of the structure that we need to create. So we have a curly brace, and then this is where we're going to have the information. For example, student ID is one of the members inside of my student structure. The name is going to be a string, which, by the way, string is not a primitive data type. String is an abstract data type. It's made from something called a class, which is also going to be learned about in this chapter. Anyway, remember, an abstract data type can be made up of primitive data types and other abstract data types, which is exactly what this is doing. Okay, and then what we also want to know, the GPA, so that could be like a float. The major could be a string. The age an int, or short. It's not very big, so let's make it a short. And then to end the structure, we have an ending curly brace, and then we have a semicolon. Now, where do you create this structure? Well, you would create it before you start any functions in your program. So if you had your entire program in a single file, then you would have this structure created at the top of the file after your pound includes, usually before function prototypes. Okay, so just to point out some of the vocabulary, the word student here, this is called a structure tag, indicating the name of the structure. Notice it's good programming practice to begin with a capital letter. So I begin it with a capital S. Also, just make sure you don't forget the semicolon after the closing curly brace. We could have also, since I have like two strings inside of this structure, we could have said string name, comma, major. So it's acceptable to combine like data types inside of your structure. And the individual variables inside of a structure are called members. It's important to learn this terminology so that you know what I'm talking about whenever I'm talking about structures. Okay, so now that we've created a structure inside of our program, we could now have our main function. And I want to create a variable of type student. Remember, this is a new data type. And so all I would have to do, since it's a data type, I have to say, what is the data type of my variable? It's a student. And then I have my variable name. I'm just going to call it my student. So it's very important to understand that up here, the code up here at the top, it creates a new data type. This code did not actually create anything in memory. So if I have memory, we're going to say this part of the code is memory, or this part of my screen is memory, then this code does not create anything in memory at all. It's not until this line inside of the main function that we actually have a single variable called my student. And inside of my student, which is a single variable, I have student ID, I have name, I have major, I have GPA, and I have age. So all of these variables are created inside of this one student variable. But it's this line right here that actually creates something in memory for me to store data inside of. So now what if I want to put Jill's information into my student? The syntax for that is we say my student, and we use the dot operator to access any of the members. So my student dot student ID is equal to 0041863. Totally making that up. Okay, so that puts, I didn't make that box big enough. That puts 0041863 inside of student ID, which is inside of my student. Okay, let's do another one. My student dot operator name is equal to, and it's a string, Jill Mouse. I don't know where I got that name. That's okay. And Jill Mouse is now stored inside the name variable inside of my student. So you get the idea of how we can enter data into that student structure that I've created. Okay, so what if I'm getting this information from the user? So instead of just a direct assignment, I have something like a cout that says enter the student's name. And we want to read that in. It's a string that could have spaces, so we just use getLine. Reading from standard input into student ID dot, not student ID, I'm sorry, my student dot operator name. It's no different than any other variable that we've used, except just the way we're accessing the members inside of the student structure is a little bit odd at first. until you've practiced. What if I want to, let's say I've entered in all the data about the student, and so this is filled up. Maybe Jill's major is CSE, GPA is 3.8, let's say age is 19. Okay, so now that we have all this information, we now want to print it out. One thing that you can't do, you can't just say C out my student. That's not going to work. So instead, it's kind of like an array in that you have to print out each member one at a time. So you could say C out my student dot operator name, and that would print out Jill Mouse. And we would have to have a separate C out for each of the members. Okay. One thing you would not be able to do, which is unlike an array, with an array we can print out each of the array elements one at a time using an index value. Notice there is no index value here for each of the pieces of data for each of the members. So we have to identify them by name in order to print them out or to read information into them. You also, so this is talking about printing it out or displaying structure members. What about comparing? What if I had two students? So I have student, my student, and let's say I have another student. I can create as many as I want. And I'm going to name it another Stu. And let's say I've already read in the data for another Stu. And I want to compare to see if these two students are the same. Unfortunately, I can't just say if my student is equal to another student. We can't compare like that. That won't work. Instead, we're going to have to compare on the different fields. So in other words, in this case, we would probably want to compare with the student ID because those should be unique. So we could say if my student dot student ID is equal to another student dot student ID, then we know they are the same. Okay, so I'm going to show a couple examples, then I'm going to stop this video. You have access to these examples in iLearn. As always, I will upload any example programs that I show in class or in these videos. Chapter 8 programs, ADT Struct class. And what you're going to do once you get into here is there's 3 programs here, Structure 1, Structure 2, Structure 3. And so I'm going to open up Structure 1. And this is good because it's going to allow me to demonstrate where the structure is actually defined. And that's something else I didn't tell you. This is called a structure definition. Okay, so we create a structure called circle. This circle has 3 members, radius, diameter, area, and they're all of type double. Then in the main function we create 2 circles, circle 1, circle 2. So it's not until line 21 that we actually have something in memory. Then we ask the user for the radius of the first circle and we read that in. Then we ask the user for the radius of the second circle and we read that in. We calculate the area based on that radius and assign it into the area member of the circle 1 structure. Do the same thing for circle 2. Then we calculate the diameter by using the radius, multiplying it by 2, and placing it into the diameter member. And this just shows if you're wanting to see if the two circles are equal, you can't say if circle 1 equals circle 2. We have to compare at least one member. It makes sense to compare the radius, because if the radius of both circles are the same, then the two circles are the same. Okay, the other example, structure 2, shows a name structure which has 4 C strings, first, middle, last, full. It shows reading in a person's first name, assuming that that name doesn't have spaces, the middle name, and then it's going to copy, using the string copy function, copy Crockett to the person's last name. Then it's going to copy the first name into full name, or into full member. Then string cat, remember that's a concatenator, add to the end. It's going to add a space to the end of the first name inside of full. Then it's going to add the person's middle name to the end, then a space to the end, then the last name to the end. So this basically, these lines are placing first space, middle space, last space into person name dot full. And then it prints out person name dot full. And one last example, structure _3, where I have a payroll structure, including an integer, a string, and 3 doubles. So this is payroll on a specific employee because we've got an employee identification number, the employee's name, how many hours they worked, what their pay rate is, and what their gross pay is. So we ask the user for the number and we read that in to employee.emp number. We then enter in the employee's name. Remember, we're going from extraction to get line, so we had to have a cn.ignore. Read in the employee's name, then we read in how many hours, then we read in the pay rate, then we calculate the gross pay based on the hours and the pay rate, and then we just print everything out. And we have to print everything out using each member, printing them out individually. All right, that's it. That introduces you to structures.